Hey guys, thanks for joining us today. We're going to give everyone a second to get logged in before we start.
It's not one thing, it's another.
All right, we'll go ahead and get started here. Good morning, good afternoon, everyone. Thanks for joining us today and welcome to today's webinar co-hosted by Viscosity North America and our favorite webinar co-host, New York Oracle User Group. We have been going 3 years strong now of co-hosted webinars together, and we love it. It has been great, and hopefully a lot of you guys are regulars of ours. And if not, welcome to those who are new to our webinar series. Today, we've got Oracle ACE Director Sean Scott presenting for us. So I'm super excited about that. He's one of my colleagues and an amazing presenter and technologist all around. It is a live webinar, so please take advantage of your time with Sean and use the Q&A field. This is a great session, so I do hope you guys use that Q&A box. If you've got any logistical issues, go ahead and throw them in there, and I'll try to get to those myself. Sean will get to your Q&A, your questions as he can, or following the session. It is a recorded session, so if we go over in time, Sean, feel free to do that. Everyone has the opportunity to go back and rewatch the recording if you've got to jump at the next hour. So with that, I'm going to pass it over for a little bit about NYOUG.
Okay. Thank you, Monica. I'm Rob Edwards. I'm treasurer at NYOUG. I'm sitting in for Coleman today. NYOUG was formed almost 40 years ago for the exchange of ideas, assistance, and support among users of Oracle software products. We can be found on the Twitter, Meetup, LinkedIn, Facebook, and on our own website, nyoug.org.
All right, thank you so much. I'm going to get my screen up here and show you guys a little bit about viscosity. If you're not familiar with viscosity, hopefully there's something here that interests you. And if so, just let me know. I'll email all of you guys after today's session, and feel free to respond from there. All right, so again, my name is Monica Lee. I'm the marketing director here at Viscosity, where our mission is to enable business transformation at a time when companies must change to survive. We are a full Oracle stack consulting firm with core expertise in Oracle database, including RAC, Oracle Apex. We perform near zero downtime migrations for our customers, performance tuning, high availability, and we've also got decades of experience with infrastructure, including engineered systems. So on this slide right here, you'll kind of see the 3 pillars that we're built upon. Across the bottom are things that we offer per pillar as well. Again, so if anything here looks like something you may need help with, please let me know. And otherwise, if these are just topics that interest you, these are things we're constantly presenting on. So please check out our events page and follow us online, so you can make sure you get that information. This screen right here just shows some of our executive management and our lead consultants. Like you see Sean here. These guys present all across the world. They're commonly found at Oracle user groups. So if you're not familiar with them and you're going to any conferences soon, such as Blueprint 4D or Kscope, you'll probably see some of these guys around. If you're at Blueprint, actually, I do have Charles Kim, Sean Scott, and Gary Gordhammer at a book signing on the exhibit hall floor, and we'll be giving away books to those who get there in time. Limited quantities. So check that out. We hope to see you at that conference, and I'll have more information for you guys on that later. This slide, real quick, the only thing I like to mostly draw focus to is Oracle License Management. At Viscosity, we've got several folks who actually came from the Oracle License Management team. And we really work hard to make sure you're only paying for what you need. You're taking advantage of the investments you've already made. And we just want to make sure everything is good to go for you guys, make the process a lot easier. It's not always the easiest thing working with Oracle to get your licenses down. So please let us help you. And if not us, if any other partner you work with can help you with that, it's just so much easier to navigate with a partner. On here, we've got a couple of our books up. I say a couple, we've got a lot more, but our newest books are going to be this Oracle Performance Tuning book. This Upgrading Oracle Database book is what we'll be giving away on the show floor in May. And then Sean's book, Oracle on Docker, recently came out, I think in the last 2 months or so. So you can find all of these on Amazon and anywhere else on the web or in a bookstore, perhaps. I don't know. All right. And I'll close it up just with a reminder for you all. OraPub is where we house all of our recordings and slide decks after webinars like today's. You can create a free membership by going to www.orapub.com. It's been part of the Viscosity family for a year now, and it was founded by Oracle ACE Director Craig Shalahammer, who's now part of our team. And we love being able to use OraPub as our training site and just really to house all of the resources we have after all of these webinars. So with that, I think I've just got a couple slides for you here. Again, in Dallas this year, Blueprint 4D is happening May 8th to May 11th. It used to be called Collaborate, if you're familiar with that. We've got 4 presenters over several days. So these are some of our many presentations going on. And then we'll also be at Kscope. Sean's actually going to be at both of them, so you can find him there and pick his brain in person. All right. So with that, I'm going to turn it back over to Rob, who's going to introduce Sean Scott to us.
Okay.
There we go.
Yeah. Sean is an Oracle ACE Director, Oracle Cloud Infrastructure Certified Architect, Professional, and Oracle Autonomous Database Certified Specialist. He's a Managing Principal Consultant with Viscosity North America, where he designs highly available and scalable databases, leads database modernization and migration projects, and coaches database teams on their journeys toward DevOps and automation. Sean is featured speaker at user group conferences and events around the world, and author of the new book, Oracle on Docker, Running Oracle Databases in Linux Containers.
Guess that's my cue, huh?
Yep, Sean, it's over to you.
All right. Thank you, Robert and Monica, for the introduction. Thank you, NYOUG, for being here, and all the attendees who are joining us today. I'm going to talk about data as code, exploring data and database portability. That's the very professional and official sounding session title that we send out to conferences. The kind of not so official title is Understanding Data Portability with Groundhog Day GIFs, because in a past life, I used to run training and training teams for Cub Scout leaders, and I learned that people pay attention to fun, interactive training. And so my gimmick has been using GIFs in my presentations. So that said, please feel free to interrupt and ask questions as we go. I've got the webinar QA and the webinar chat open on my screen here as we go along. So again, please feel free to jump in and do things. I think that Rob gave an introduction very briefly. This is me. I've been working with Oracle since the last century, and most of my focus is on database reliability engineering and DevOps upgrades and migrations. And as Monica mentioned, I just wrote a book. I have a sample chapter on persistence in database containers and Docker containers that's available for download for free on my blog. That chapter goes really deep into some of the concepts I'm going to be discussing in today's session. And as I said, I've worked as a DBA for a while, and I can say that most DBAs probably see ourselves in a certain way. And I may be generalizing just a little bit, and you may agree or disagree, but I do know a lot of DBAs with really massive egos, and that doesn't always make us really approachable or easygoing. So in a lot of shops, and again, I'm generalizing, I apologize if this doesn't apply to you, but in a lot of shops, developers and DBAs are at odds with one another, if not actual enemies. From the DBA side, and I've worked both sides of this, I started out as an app developer and kind of fell backwards into becoming a database administrator. And as DBAs, we are cautious. We take our jobs very seriously. We have very serious responsibilities managing the data for the enterprise. And as a side effect of that, we tend to be very resistant to change. And we can even be a little bit closed-minded to new things. So it really isn't unusual that you will see a shop that has standardized their entire infrastructure stack, everything, on something like Kubernetes or containers or a particular compute shape, whatever it may be, with the exception of the database. And there's a reason for that. And it's because as DBAs, we go around saying that databases are special, and we get away with this. In today's session, I'm going to talk about how we decouple the DBA from the development process and eliminate a lot of the compromises and adjustments that we've had to make in our test and QA and development cycles. And really what I think is most important is eliminating the friction between DBAs and development teams. So you're probably thinking, what does all this have to do with Groundhog Day? Well, hopefully you know the film. If you don't, or if you need a quick reminder, Bill Murray plays this arrogant TV weatherman named Phil Connors, and he's sent out to cover Groundhog Day festivities in this tiny town of Puxatawney, Pennsylvania. And he gets stuck in the town because of a blizzard, and he ends up repeating the day over and over again, repeating the same morning timeline. And that's kind of like acceptance testing, isn't it? We're just doing the same thing over and over, making changes, making tweaks to see if we get different results. So we could kind of look at Phil as a microservice, and the first time through, it's a normal day. We're on the main branch. This is the Phil Connors main branch. And unfortunately, our customers said that Phil Connors microservice, he's kind of unlikable. In fact, I have some comments here from customers. They said that he's a narcissistic tool. So let's see if we can maybe make some changes to the Phil microservice. Marketing's asked us to redesign him to make him into a better person. And so really the best way to know if we've satisfied this feature request is we observe and measure his behavior against a known baseline as we make these iterative changes. So the first time through, we branch off of the main branch and we have our day 2 branch, and we run it against our data set. And Phil's a little bit confused in this branch, but he's still a jerk. So let's make some more tweaks to his code. Well, here we are. Phil has kind of adjusted the situation. He realizes that he's in this loop. He's become aware of things, but nobody else knows what's going on. So he enters the bank robber branch, where he realizes he can really safely go to the back of an armored car and steal money bags from the truck and then spend the day living it up. But he only knows this because the timeline that everyone else experiences is identical until he interacts with it and changes it. So Phil's code base is the only variable we have in this otherwise very constant system. And we go from bank robber to piano student, where he realizes, well, this whole grand larceny thing, not very fulfilling. maybe I should try to make myself into a better person. So as he goes along, he accumulates experiences on each branch, takes the opportunity to learn piano, learn French, all sorts of different things. And finally, at the redemption branch, Phil becomes a better person. He finds his redemption. He's released from this endless cycle of day after day reliving Groundhog Day. And so at this point, we make a pull request and we push the new Phil to production. So now this only works, all this iterative testing that we're doing, it only works if everything in our Punxsutawney test database, that each branch that we're testing interacts with the same data. Phil should be the only person that can have any awareness at all that he's in a loop. Well, what would happen if we let the database roll over to the next day? Well, now it's February 3rd and it's not Groundhog Day anymore. And the blizzard that we ran into, it passed the night before. And there's no need to take the segment because it's not Groundhog Day anymore. And he doesn't run into his old friend Ned, because Ned sees him, thinks, oh man, I met Phil yesterday. He's a jerk and I avoid him. So really the only thing that we would have in this test, the only thing we can compare against is the alarm clock going off. So all of the changes that we made to the Phil repo would fail, but not because of any problem in the code. They fail because the test data changed. There are my animations. There we go. But what if that February 2nd data set that we had gets polluted or it diverges from where we thought it was going to be? So if the alarm doesn't go off, well, Phil's not going to wake up in time and he's not going to go out and have all the experiences. Well, what if Ned's job changes and now he's the president and he's surrounded by this Secret Service detail? Well, could he interact with Phil in the same way? Probably not. What happens if every time we ran a test, it inserted an additional groundhog into our test data? Probably be pretty confusing. And the whole story isn't going to work if we move the location to Miami. So the problems that we encounter with this is every test that we perform in a traditional environment where we have multiple users running individual or isolated tests against a shared or monolith database is that every test is polluting the data. And restoring that database is very operationally difficult for us because it requires some amount of downtime. I did a presentation several years ago, and I was talking about production and test databases. And I had a guy in the audience, he says, well, there's no such thing as a non-production database because somebody is the consumer of that database. And if they consume that database, that's their production environment. And there was a back and forth and it was a spirited discussion, but he's got a point. So if we need to take an environment down to restore data, it's inconvenient. We're going to have to coordinate that activity if we have a number of users sharing that data. And we're also going to need some specialized skills from the DBAs to do that. And that's how we get database administrators or DBAs embroiled in our development cycles. So there are some solutions that we could look at. We could build some exceptions or some sort of elasticity into our CI/CD pipelines or our QA process. We can make assumptions that certain errors are ignorable, but these are all based on a very traditional view of databases and data. And in that traditional view, we look at data as some sort of random result. It's this living, evolving thing that isn't very well defined. And things that aren't well defined are understandably difficult to codify. But every data set is expressible as code, every single data set. There is no magic. Databases do not come pre-populated with customer data. The data gets in there somehow, and that data gets in there through code, one of 3 or 4 ways: an insert statement, an update statement, a delete statement, a merge statement. So the exact state of a database can be recreated by replaying those transactions in order. Okay, well, that sounds like a lot of work, doesn't it? And that sounds difficult, but on the database side, We do that all the time. And when I say all the time, I mean we're doing that literally constantly. That is what change data capture is. Change data capture is taking data as it is inserted into a database, converting it into SQL statements that are a standard and transmitting them to a target database. And that's how I can replicate an Oracle database to MySQL or Postgres or back. I can even do data transformation in flight in the SQL phase, where maybe I can go in, I can scrub out sensitive information from a production database. So change data capture is data as code, but it still does require a DBA and some sort of elevated access and knowledge of the environment to make it work. And I want to bring that up, though, to demonstrate that data is code and that it is far more commonly and easily defined as code than we typically think. Which brings me back to this whole idea that databases are special. And remember I said that DBAs don't like change. Well, databases are special is the get out of jail free card that lets us as DBAs, and I am guilty, it lets us avoid change. Because we say, well, you know, if data is the new oil and DBAs are in charge of the refinery, when somebody says, oh, can we make the database cloud native? The answer is going to be no, well, we shouldn't do that. Which I don't know if anyone's heard this joke before. What does DBA mean? Anyone? Anyone? Don't bother asking. Yeah, the answer is probably going to be no. That's what we say as DBAs. And I'm guilty of that too. I poke fun at myself. And we get away with it because nobody really knows any better. And it's why you will see organizations that are absolutely 100% cloud native in everything they do, containers, Kubernetes, everywhere, with the exception of a handful of databases running on VMs or bare metal in legacy configurations. And that's reflected here. This is a great book that I really highly recommend. It's called Database Reliability Engineering, Designing and Operating Resilient Database Systems, published on O'Reilly. Lane Campbell and Charity Charity Majors are the authors of this book. It is a fantastic book, even though it is a few years old, everything still applies here. And so you look at this quote here, this is from the preface of the book. For a long time, DBAs were in the business of crafting silos and snowflakes. Their tools were different, their hardware was different, and their languages were different. Sounds pretty ordinary, pretty common. That's how we do it, right? And it says databases are special. I mean, this is implying that databases are special and we can't treat them like ordinary systems or infrastructure, right? Well, then they go on to say, the days in which this model can prove itself to be effective and sustainable are numbered. Well, that's disappointing. And if your bubble wasn't already burst on this, our systems are no more or less important than any other components serving the needs of the business. The components of database clusters are not sacred. That is shooting at our foundation, the whole foundation of this databases are special notion that we have. And I really do, I highly recommend that you get a copy of this book if you're DBA. I like to go in and read it or reread it at least once a year, just to kind of remind myself of some of these principles and get me out of some of the bad habits. But the bottom line is that as DBAs, we have projected and we've perpetuated this idea that databases are different and that they are exceptional. And we use databases are special, that phrase, as the reason not to introduce things like DevOps principles, configuration management, version controls, infrastructure as code methods to the database tier. It is our excuse. But all of that is based on a lie because databases are not special. This is not a database. Data is special. Data is the configuration and the data part of the database. The database is software. The database Software is just an application. It's the rules that manage the data, that determine how we process that data. So of all the infrastructure in your environment, I would argue that the database is the most critical for you to wrap in configuration management and provision with infrastructure as code methods, because while the database isn't special, the data is. And the engine that processes the data should be very, very tightly controlled. But the reality is that I very rarely encounter database environments with any sort of formal controls. For the most part, we tend to maintain everything by hand. And as someone with feet in both the database and operations spaces, it really personally drives me nuts, because I've seen the value gained from the structure and discipline and formality of these processes. Okay, so what does any of this have to do with data portability? The preaching, how does that decouple the DBA from the development process and eliminate the friction that I was talking about between DBAs and developers? Well, there's this thing called cloud native, and it's a buzzword you've probably heard a lot lately. Basically, cloud native is sort of a bucket catch-all term that covers all sorts of sins: serverless, functions, containers, Kubernetes, all the nasty words. But the piece that we're most interested in for this discussion is the container piece. And I want to just talk really quickly here about what a container is. Would anyone like to take a shot about what a container is? What is a container? Is there a quick, succinct definition that anyone has? Anyone, this is a lot more fun in a live environment where people can shout things out. So I will just jump ahead and say, please, whatever you say, don't say it's like a lightweight virtual machine, because that is a terrible analogy. It tells me absolutely nothing. I have a really vague idea of what a VM is, but what makes a VM light? And how is a lightweight VM like a container? I'm comparing something I don't understand to something I can't really describe. So I look at a good analogy as something that takes a thing that I'm familiar with and relates it to something that is more abstract and gives me a mechanism for understanding things. And a really good analogy that I keep coming back to is this water hose analogy, or the water flow analogy for electricity that I learned way back in high school physics. And to this day, I cannot think of an electrical circuit without visualizing everything as a collection of hoses and water pumps and kinked or clogged hoses for resistors and so forth. It makes this very abstract concept a lot more accessible, and it helped, for me, relieve a lot of fear and doubt. And I think that as DBAs, when we look at containers, we have fear and doubt because we don't understand them. Because when somebody says a container is like a lightweight VM, well, we don't really understand what that is. And that's a very common explanation or description of what containers are. So fortunately, I put together a better analogy, at least I think it's a better analogy for what containers are, that does a better job, I think, of helping people understand what they are and how they work. And this is it. This is a container. It's a game of tic-tac-toe. Container basically is a unit of software, and it does some work for us, like playing a game of tic-tac-toe. So we can go in here, and this is our container. I play a game of tic-tac-toe, and if you're familiar with the whole concept of containers, they're typically considered ephemeral, meaning we create them and we delete them. So this fits very nicely. We played our game of tic-tac-toe, and now the game is over. We would just destroy it. We would throw it away. Certainly not something we want to do with a database, but bear with me for a second. What you probably didn't spot here is that this container is really two things. See, behind or beneath every container is something called an image, and that image has the playing surface, and it's got all the rules for the game. And the container is just that thin, transparent plastic layer that we superimpose on top of the image. And that layer, that's what records all the moves that the players make in the game. But the rules are here in this, the stateful, perpetual image that we have in the background. So a couple quick definitions. An image is the game board and the rules. Containers host and persist our games. And that superimposed container layer is where we save the moves. And if we delete a container, we're removing its layer. And this is the secret sauce that makes containers so fast. I don't have to draw or redraw my tic-tac-toe game board or rewrite out the rules every time because they're already in the image. I just go and I pull the image, I put a piece of plastic over it, and I play my game. And it's also why containers are so popular for infrastructure. I have one image that can be the background for dozens or hundreds of containers. And that one image is guaranteed to produce identical results for every single container that runs from it. All of those containers, all that they are is just that thin sheet of plastic. And anything that we write on it, meaning that we can get really amazing density on commodity hardware by running containers there. We have the one big image that we use, and then dozens or hundreds or even thousands of really, really thin sheets for our containers. So I said before that this image, the whole game board, that it's stateless and that it can't be changed. And to understand why it is so important that we don't change that and can't change that, I'm going to play another game of tic-tac-toe for you here. And here again, we've got the image, the game board in the background has the rules of our game. And no matter how many times we play this series of moves, we will always produce a stalemate because this is where the game board is. This is what the rules say. But what would happen if I could change the image behind the container? In this case, we're just going to shift it to the right. Well, I changed the rules. I changed the game board for my game. And now all of those moves in the left column, they fell off the board. And I've got spaces on the right where we can continue making moves. And at this point, the O player in blue cannot lose this game. So in the game of tic-tac-toe, it lets people cheat. But in the database world, it would mean that we would get different results from the database, or the database may not behave the way that we expected. So this whole idea of immutability, it's what guarantees that a container produces identical results in every environment. And that's the whole principle and the whole attraction behind cloud native, is that containers are portable. You may have seen the meme where, well, it runs on my machine. Well, let's ship your machine. That's the whole idea behind containers. They're portable, and with very minimal effort, I can lift and shift a workload from one cloud to another, from on-premises to cloud, move them from machine to machine. It's a very powerful capability that we have with containers. But if you consider this in the context of databases and data, and more importantly, things like high availability and disaster recovery, well, then we get into some really cool things. See, if your database, if your production database especially, is this handcrafted, hand-created, unique snowflake environment, what happens if your host dies and you have to reinstall the operating system and reinstall the software from scratch? How do you guarantee that the operating system, apologies for the dogs, how do you guarantee that the operating system and the database software installation and all of the patches and your kernel settings, everything, how do you guarantee that it is identical to the original system and that your test environments are functionally identical to production and will produce identical results from test through QA through to production? Well, you can't if you don't have that guarantee. Well, containers solve these problems very elegantly. Databases, again, they're applications. That's it. It's a set of rules. And every database is going to have some sort of configuration or property file that says, hey, I'm a database and there's a directory over here where my data goes. Maybe it's multiple directories. And in a container, that newly added data, the player's moves, well, you saw that we wrote those moves into the container layer, into that thin sheet. But what happens if we delete that thin sheet? Well, it's like taking that container layer and dropping it into the shredder. When I delete or I drop that container, the sheet gets destroyed. All of the moves and all of my data would be removed from the system. Now, I want you to notice that I said delete or drop a container, not stop and start. There are a bunch of blog posts out in the world that say all your data vanishes when you stop a container, and that is not true. It's preserved in that container layer. That container layer persists until the container itself is deleted or dropped. And some of that misinformation is partially or wholly or majorly responsible for a lot of DBAs saying, well, containers are bad. So we have this really cool feature in containers called a volume that lets us persist data outside of the container. So we have the container still, we have our container layer, and then we have some local disk or a shared disk or high performance network attached storage, whatever it may be, where we can put our configuration and our data. And with a volume, what I'm saying is, hey, everything beneath this directory, I want you to save it to a special place, to a volume that I'm going to define separately, that is separate from the container. So instead of that data being on the thin sheet on the container layer, it's saved in persistent disk and it's decoupled from the container. So if I drop the container, it doesn't destroy any of my persisted data. So we can do this thing called bind mounting a volume, and this is just sort of a quick technical look at a command that we might use for doing that. And now anything that we write to that directory, in this case, we're calling it our ORA data directory, or our data directory, anything that's written there goes into that directory, and now I can manipulate it. It's a set of files, and I can manipulate that with regular OS commands. Okay, so what good is that? Well, I am going to perform a little bit of a magic trick for you. So remember that our image is the game board and all the rules for playing the game. And the container is the host or hosts and persists our games. And one of the rules that we have in our image, the rule that comes first before anything else, is what to do when I start a new database. And for a database, it performs this check. It says, hey, is there database configuration out there? If there is, if it finds one, it starts the database. If not, it says, okay, I don't have a database. I'm supposed to be a database, so let me create a database. But the container doesn't have any knowledge of whether this is the first time or the 100th time or the 1000th time that it started. It's just following the rules embedded in its metadata. So I could do a magic trick like this. What if I were to start a brand new database container and tell it to use a volume for my data, but instead of a brand new empty data volume, I put a database there? Well, a container doesn't know any better. It just looks where it's told. And when it looks there, it finds a database and it says, oh, hey, look, here's the database that I'm supposed to start. And it starts the database. So when I say put a database there, I don't mean restoring a database with RMAN or recovering a database or anything like that that requires any kind of DBA commands, no export, data pump, nothing like that. What I mean is literally just running a copy command where I'm copying the contents of one directory into another. Or I could maybe copy the data out of an NFS mount point of gold data into my local environment. Or I could even take something off of a network file share that is maybe date and time versioned and copy that out. Because if data is code and code is versionable, that means data is versionable too. Okay, so what do I mean by versionable data? Well, let's jump back to our Groundhog Day database. And at 6 a.m. on February 2nd, the absolute first thing that happens is Sonny and Cher jump onto the clock radio and singing. They start singing "You Got Me, Babe." Well, that is our baseline database. That is our version database. And in this database, we hear Sonny and Cher. Ned hasn't seen Phil for years. The groundhog hasn't made its prediction, and the blizzard hasn't hit yet. And so when I point an application at that database, I can be absolutely certain that it is going to behave exactly the same way each time because there's no polluted data. that might skew my results. There's nothing to give any clue that Phil has been living this day over and over and over again, with the exception of Phil's data. Okay, so we've seen that Phil, as he moves through these different branches, that he becomes more aware of things. So how does Phil, in this baseline database, how does Phil know the exact moment to take money off the armored truck, or the answers to Jeopardy questions on TV at night, how to play the piano? Where in this database are we saving all this information about how Phil is evolving and growing? Well, Phil isn't actually in this database. This database that we're working from is that main branch of Phil Connors. So we need a way of updating Phil, of rolling Phil forward to match the code branch that we're testing, while keeping everything else at that main level, at that originating level. So we could do that by manually running a bunch of SQL statements to bring Phil up to date, and then saving the data like we did before, copying any version of the data to our test environment, starting a database container, going through all of that work, storing all of these large data sets if we wanted. But that is a pretty heavy-handed approach, because if you look at Puxatawny, it's a town of about 5,800 people. So it doesn't really make a lot of sense to have multiple versions of all of their data when it's all going to be identical anyway. So instead, what if we have a database for the town, and then we apply some SQL just for Phil, to bring Phil up to date on the branch that we're testing? So here we are applying something called lean principles to our version data. We have our single data baseline that we begin with, and then we can roll forward through any number of independent scenarios and allow multiple developers to work on each of their independent features and changes without worrying about contaminating the data for anybody else. So it looks something like this. Our data is cumulative. So we can create our data set, we can have our day 2 data set, we can have our day X data set. And if we just apply those SQL scripts progressively from each branch, we get to the ending point that we want to reach. So we can take that baseline Puxatawny database from February 2nd, apply all of our different SQL that bring Phil's dependencies up to date with the branch that we're testing, and we'll get our good test results. And we can even do this automatically using a special directory in our containers called an entry point. In containers, an entry point is the special directory where you can put scripts, and at some point, the image metadata says, hey, and now go and look in this entry point directory and run any commands that you find there. So there's no formal definition for entry points, and every image is going to treat entry point scripts a little bit differently. Some have multiple entry points, some have specific entry points for startup and setup, so that you can create a schema when you start versus, you create a schema after you initiate a database. Or you might have these startup scripts that perform some maintenance activities or administrative actions every time you start the container. Other images are going to have a single entry point that just runs the same thing on every startup or just the initial step. You need to read the documentation. Oracle's container images are really good about this. They have separate setup and startup entry points. And so what this looks like for us, we would change this command and we would start the container with our baseline data. And then we would put in our entry point the scripts under whatever directory to run automatically and update all of our dependencies for us as part of the startup, the setup of the database when we first set up the container. And again, if our data sets are cumulative, then we can create any given set of data by just applying sets of SQL progressively to reach any given point in the life. So as a general rule here, when we're looking at this ancestor data, we want to save whatever the oldest baseline is that we will need to use. We'll save that as a data set, and then we'll have version SQL that creates all of our descendant or all of the iterative descendant sets as modified data that we modify through those SQL scripts or SQL statements. And so that way we can reach any point with a single data set, flow through to any point or modify features to reach any stage in our development cycle. And so if we return to our Phil Connors database, we have each branch here that has its own SQL, and we just apply the day 2 branch, the bank robber branch, the piano student branch, and the redemption branch, all of that SQL. We apply all of that. It brings our Phil Connors microservice up to date. And once we're happy with our modified Phil Connors, we can merge him, we can push him to production, and boom. At that point, we can start testing the new Phil, where he and Rita hopefully live happily ever after. So just to quickly summarize, when we're looking at data as code, we're decoupling our data from our database, because databases, the software is just that. It's just application software. There is nothing special about the database software. We're decoupling that from the data, which is truly important and valuable to us. And it lets us, through data as code mechanisms, let us standardize that data so we can have data artifacts that we can pull from a repository, store in a repository, manage through version control and so forth, and provide to developers so that they can reach these development points that they need to test their code. And we're completely decoupling the DBA from the development lifecycle here, because we don't need any kind of specialized commands. We don't need someone to run an rman restore or import, export data, nothing like that. This is just straight file copies. It's just files on disk, that's it. And when we decouple the DBAs from that system, and when we make this available, when we democratize the data and the access to data, we're going to have much faster, much more streamlined development life cycles, where developers aren't encumbered with any of these other practices or policies or requirements, or needing to get clearance from anybody because they're working in personalized local data sets. And that is going to give you a much higher reliability and quality for your tests. So you're not getting into a situation where you run a test and you say, well, we got 30 errors from this, but they're all ignorable errors. So they're all errors that we can overlook. You can have absolutely a binary pass fail in this case, because you've got data that is clean. So if anyone has any questions, please feel free to shout them out or drop them into the Q&A or chat at this point. I know Monica has a copy of these slides that she'll send out to everybody, and then she also has, we'll post a recording of the webinar as well.
Last
Questions?
call for questions.
Questions, anyone?
And yes, like Sean said, I'll send you an email when the recording is up. So just like Groundhog Day, you can relive this last hour of your life over and over and over again. But if no questions, thank you so much, Sean. That was such an entertaining session. And Rob, thank you and NYOUG so much for co-hosting this with us. Be sure to follow Sean on any of these resources up on the screen. Otherwise, you can find all of this at www.aurapub.com. Give us maybe about a day, and it should be there.
I do have a couple questions here. First one is, what is your book again? If you go here to oraclesean.com, there's a blog post that should be at or near the top, and it'll have a link to the book. It's called Oracle on Docker. Oracle on Docker, running Oracle databases in Linux containers. And again, there's a sample chapter there on persistence. Then it'll have a link. You can go to the Apress site or to Amazon, Barnes & Noble, all have it available for sale. Another question here, may please know if there's any online training or webinars for databases, SQL, Docker, Cloud Tech Fundamentals. It'd be helpful if you please point me to it. there's a ton of stuff out there on YouTube. I have some on my YouTube channel, and I'm been really slow in updating it. I'm sorry. I have 5 or 6 different videos recorded that I just need to edit and post on YouTube that walk through how to install Docker, how to set up containers and do all of that stuff. So if maybe you can be patient until mid-May, I will have that up. I've got Blueprint coming up again, so that's going to be fun. Yeah, actually, here I'll post the link here. It's youtube.com/Oracle. It's got an underscore. And it is here in the slide deck on the end page in the slide deck as well. And if there aren't any other questions, I'll turn it back over to Monica. And
Great. I think we've gone over everything. So thank you guys so much. Look for that email from me, Monica Lee, and you will get instructions on how to find everything through AuraPub once they are all uploaded. So thank you guys so much. And again, there is a free tier for AuraPub. There are also paid memberships you can sign up for if you'd like. They just come with a few more perks. And hopefully you can get your employer to reimburse you for it. But yeah, check it out if you're not on AuraPub already. Hopefully most of you are just from attending these webinars. So again, thank you guys. Sean, I'll see you in Dallas at Blueprint, and hopefully we'll see some of you guys too.
definitely. Thanks everyone for being here, and thanks NYOUG and Monica for setting everything up and hosting. Appreciate it.
Thank you. Take care.